All right, well, welcome back to ElmLive. Today is November 26th, 2016. And what I wanted to try doing this morning was fix up the problems we ran into last night on Codevember day 25. So we were building a little board game, and we were trying to make it so that the board itself would get changed as you moved pieces around. And we ran into a problem kind of doing one of the final functions to make that work. And last night I was just totally stuck and could not realize what the problem was, but I figured it out over the night. So I wanted to do a quick stream this morning and just wrap this up, and assuming this doesn't take too long, then I'll probably do another Codevember project later this evening. So let's see. So just a quick overview of where we were at. We have our main function with a model that has a board and a selected tile. Our update function, when we choose a tile and then choose another one, it calls this makeMove function on our board. And that's what we're mainly modifying. And we also did a bit of refactoring yesterday to split up how it renders, so we can render the tiles and we can render the pieces that may or may not appear on a tile. And then our makeMove moves a piece around, and we're working on building this new function, Terraform board, which takes a set of relative locations and a center location and a target location. And the idea is that this is going to take the tile colors from the positions around the starting center, pull those colors off of the board, and then push them down on top of other board locations. And then each board essentially can be a stack of colored tiles, or each tile on the board. I guess we don't have a great terminology. I guess I've been saying that each tile on the board contains a stack of colors. And if there are no colors in the stack, then the board square doesn't exist at that tile, and pieces won't be allowed to move onto it. Okay, so the problem we had last night was we kind of had mapped out the chain of processing that we wanted to do to implement the algorithm that I just described. So we start with a set of relative positions. Then we were going to, from that, get a set of from and to positions. Then from that, we're going to figure out what tile will remain at the from location for each one of those, and also what color is going to be pushed onto the to position for each one of those. And when we started doing this, we started getting this type error, and let's see if this is the same thing. Yes, okay. I'll pull it up on both screens here. So we were getting this error saying the function should be int to position list color, maybe color position, blah, 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 but it is actually this. And what confused me last night is this error message is misleading in a couple of ways. The first way is that int, int actually is the same as position. So this difference is actually not a real difference at all. And the second problem is that it doesn't, what's really wrong is the right side here. And it doesn't really explain why. It gives this hint, which actually is the problem. The problem is we're producing a set, and every value in the set needs to be a comparable value. And the problem is that color values are not considered comparable. And also earlier we had our tile. We actually had tile in here as what we really wanted. So neither tile nor color are comparable in Elm in this version, although adding that is planned in a future version of Elm. But currently neither of these are comparable. As a result, this entire tuple is not comparable, which means we can't use it in our set. So that's kind of unfortunate, but the fix for this is if we just convert our set into a list, then we can map over the list, and the things in a list don't need to be comparable. So let's do that. Relative froms, and then we're going to set.toList that, and then we can use list.map with our function. And that should work if we now expect a list. And let's see. So pull top color, then remaining tile. We had destructured this to try to debug what was wrong. Okay. Whew. All right, so that finally works. So these two steps we kind of did all in one go, and this is now a list instead. So now that we have this list, let me pull these up. So this is essentially our description of all the movements that we need to make. We're going to, yeah, right. Okay, so our next step is to process each one of these. And the first thing we need to do is take all of these tiles and put them back onto the board from all of the from locations. And we'll end up with our new board from that step, and then just these maybe colors that then we need to push onto things. So let's call it this. So we'll say with tops removed, and this is going to give us, and actually I'm realizing, and this would be a list, we can just use the same movement list for both cases. First we'll process the board to remove the tops using just these parts, and then we'll use, then we'll create our final board by processing it with just the two sides. Okay, so then this is going to be a new board. Actually, I'm just going to say this is a dictionary of position to tile, because we don't need to keep destructuring and rebuilding this board record. So with tops removed is going to equal our starting tiles, and then I guess what we want to do is fold over this list, and for each one of these kind of actions or processing steps, we want to apply it to this dictionary. So I guess that means we're going to do a list.fold, and by default I use, like, the direction here doesn't really matter, but using fold L, if I am remembering things correctly, has better performance characteristics by default. So we're going to have a function there in a minute. Our accumulator is going to start with the board.tiles, and that's what we're going to modify in each step. And then the list we're stepping over is our movements list. Okay, so then what are the arguments we're going to get here? Our first argument is going to be the item from our movement list, and that is going to be the position that we're changing and the tile, and we don't care about these other two things because that's going to be used in the next step of the process where we push the new colors down into the target locations. And then we're also going to get our accumulator at each step, and our goal in this function is to return a modified version of the accumulator. Okay, so what we want to modify is basically take this new tile and put it in this position. So that'll just be dict.insert at the position with the tile and into the tiles accumulator. Okay, and that type checks. So then our final step of our processing, so that took the place of this step. Then our final step is we want to apply these new colors onto the two positions. So with colors pushed, so this is also going to be just a dictionary, which is our representation of all the tiles. So this is going to also do a fold over the same list of movements. So we'll have a function to write in a minute. And our starting accumulator here is going to be this one that we just calculated. And then what we're going to fold over is our list of movement instructions again. And then our function here, our first argument is going to be the item from the movements list. So in this case, we don't care about the first two elements in that tuple. And then we have the color to push, which is a maybe. Some people like to call this like maybe color, but I tend to just use the simpler version of the name, and we can tell what it is from the type errors if we get any. And this is the position that we want to push this color onto. And then we get a second argument, which is the tiles dictionary that we are accumulating into. Okay, so we're going to need to use one of the helper functions we wrote last night. This one, push top color. And we are basically going to be taking the color and pushing it onto the tile that currently exists at that location. And we're going to have a maybe color. And we also are going to have a maybe tile. So I'm wondering if there's like a maybe.map2 function that lets us take two maybes and call a function on them. Let's see if there's already a function like that in ElmLive core. I would expect it to be in the maybe package. Okay. Map2. Yeah, great. Okay. So this essentially is our function. In our case, A is the color, and B is the tile, and value is also the tile. So this is our push top color function. And then we're going to pass it a maybe color and a maybe tile, and we'll get back a new maybe tile. Hey Proton, welcome to the stream. All right, so let's see if we can write this. So we're updating this dictionary, and we looked up the docs yesterday for this dict.update, which takes a function that is given a maybe tile. So we're going to update tiles at a particular position. Let's see. So let me make sure I have the argument order correct for that. Although I guess the compiler would tell me in a minute, but okay, so update takes a key, takes a function that in our case will be given a maybe tile. We need to return a maybe tile, and we are going to use our maybe.map2 to call our function with a maybe color. Okay, so this is going to get the tile, and we want to call maybe.map2 and pass our maybe color, which we get from this, which was the movements instructions that we're folding over. And the first argument is actually our function, which is push top color. Let me split the line here. And then our second thing is the tile. And let's see, is that it? That works. Okay, so now because this argument is the same as the last argument here, we can curry this and just pass this as one argument. And actually tiles here can also be curried. Not sure that one is super readable. Okay, so that's our with colors pushed. And the only weird thing here is we have this weirdly named function called f. This, I guess we can call just create movement or calc movement. And calc movement, I'm just going to put the type annotation here, takes an int, and gives back, yeah, I was trying to distinguish these ints, which are relative coordinates from these positions. Even though they're actually the same, I just feel like there's a subtle distinction there that I want to make clear. So here we're taking these relative coordinates and producing a from position, a tile, a color, and a to position. Okay. I'm going to remove these comments. So it should all be clear here, and hopefully from the names. Okay, so now we've calculated the new set of tiles in 2 steps. Well, in 3 steps. First we calculate what needs to happen, then we apply the removals, and then we apply the pushes. And that gets rid of this function that we wrote last night before realizing that the order of applying those transformations matters, or we could end up with a messed up board. If we removed and pushed the colors one at a time, then we would have to do some complicated ordering to make sure we didn't overwrite things that we needed. Okay, so now that we've calculated this, we should be able to just stick this into the board. We're going to replace tiles with our newly calculated dictionary. And that, should almost be that. The final thing we have to do is actually use this function when we do our make move. So, okay, so here's our game. It currently works as if nothing had happened. Right. And what we set up at the beginning of yesterday was we made this new piece type. So there's special pieces that terraform the board. And each one of those pieces has its own set of essentially like the shape of tiles that moves with it. So we need to start out by creating some of these pieces. So I'm going to change all the black pieces for the moment to be these terraforming pieces with our T shape, which we defined. Okay, and this pink circle around them indicates that they're terraforming pieces. What I'd like to do is actually maybe draw the set of pieces onto the piece, or draw the shape of terraforming onto the piece. But for now, we know all the shapes. So let's see. So now what we want to do is use our terraform board function in our make move function. So here's what we want to do. We'll have new tiles is going to equal, and we need to do a case based on the piece that's moving. Okay, and piece is a maybe because we get it out of a dictionary. So if we have a just terraforming piece with a shape, and our shape is just that set of relative tile locations, then something, and otherwise we're just going to return our existing board.tiles. Okay, so in here is where we want to use our terraform board. And interestingly, we don't actually need the entire board here. This can just be changed to a dict of position to tiles. And then this will just be called tiles. And in the end, all we're returning is the with colors pushed. And that's just tiles. And up here, this is also just tiles. Okay. So I think it's usually nice to do that and make this function as reusable as possible, especially since this is a private function that we're not exposing. All right, and then here, terraform board needs the set of relative coordinates that are being terraformed. So in our case, that is the shape here. Then it needs the from location and the the from position and the to position, which we have. And then it also needs the existing or the starting tiles. And what's wrong here? We also get a player in this tuple, and it doesn't matter which player is which. Great. So now we have new tiles. And then, finally, we are going to stick the tiles in here. And this extra case, let's see, if there's no piece to actually move, and if the move is not valid, then we don't want to update the tiles either. Okay. Well, let's see if this works. So what should happen? So I'm expecting this red part and the yellow above and below. I guess you can't see my mouse. Let me pull this up here. Okay, so I'm expecting when I move this selected piece that this yellow and this red and this yellow and this yellow are going to be moved along with it. And it looks like that is exactly what happened. Cool. And then if I take this, it should move. There's nothing to move here, so it should move this yellow, red, yellow along with it. Oh, I can't actually move it here because there's no movement allowed. Interesting. And then the other thing should be that if we move one of these next to another piece, then the tiles under it should change, but the pieces remain. Okay. And we can also move the color out from underneath a tile. Oh, we can't actually, because no tiles start next to each other. Interesting. So let's see, if I move this white piece here, and then move this piece over here, okay, yeah, then the color underneath it goes away. Okay. So that actually is what I ultimately wanted. So there's a little bit of extra things or a few more extra things. It's still early. I'm tripping over my words. There's a few extra things that I want to do. One is I want the terraforming pieces to be allowed to move to an empty, like an uncolored tile. So let's check that. So isValidMove is checking to make sure that there is no piece. Interesting. So I'm not actually sure why it doesn't let us. Oh, actually I know why. The reason we can't move to a totally empty tile is because there's actually nothing visible on the screen, and as a result, there's no onClick event attached to that. So I think what we need to do here is, if we have an empty tile, we'll actually draw something, but we'll just draw an invisible, like a transparent object, and we should be able to click it then. So let's try this. I can move this out, and then can I move this piece into there? Okay, great. So that solves that problem. The other thing I'd like to try to do is render these shapes on the terraforming pieces, so that like this one will show on top of it a little indicator showing the shape of tiles that will move when you move the piece. So that is, okay, here's where we render the tile, here's where we render the piece, and here's where we render our terraforming piece. Okay. And currently we're drawing a pink circle underneath. So actually, instead of that, we want to draw something on top. So we'll move that down. And what we want to draw, this will be the shape. I want to loop through each of the relative coordinates in there and draw a tiny little square for each piece. So we are going to set dot, to list. Let's check if there are any other useful functions in the set module first. So we can query, we can union, intersect, diff, to list. Okay, so there's a fold, which could accumulate things, but we'd have to manage that ourselves. There's partition. Okay, yeah, let's use the to list of the shape. Then we'll have a list, and we'll list.map each of these, and this will get a X and Y. And for each of those, we are going to make a rectangle, which is going to have a few attributes. I'm just going to copy this from up here. Okay. So I think let's just make these one by one little squares, and we're also going to have these filled. And I guess we're going to do the colors, but just reverse the colors on the pieces. And then I guess we also need to transform this. svg.attributes.transform. And this is going to be a translate by some amount. And this is going to be toString of, I guess, x times 1.5 2, because I want them to be separated a little bit by some blank space. And then we'll have a comma, and then we'll have toString y times 1.2. Okay. And what did I mess up here? Attributes. I spelled attributes wrong. And we need to import set. And what else is wrong? I think we have some extra junk here at the end. Great, so we can delete this pink circle. And then finally, we end up with a list of SVG elements. Okay. And the first problem is we're getting integers here, and we need to convert those to floats when we multiply them. Let me put a line break there, to float there. Okay. And now we're getting a list of SVG elements when we really just need one. And kind of a confusing thing is HTML and SVG actually are type aliases for the same virtual DOM type. So the problem is we have a list of things instead of one thing. So to fix that, we will just put these in a group. Oops, and I put this in the wrong place. That comes after our map. So there's a lot of nested code. Definitely we could refactor this. And probably like here would be a good place, or actually this, pulling out like a render piece function, and maybe even putting piece related stuff in a separate module would be a good refactoring. But I am mostly concerned with getting this to work at the moment. Ooh, perfect. So that is exactly what I was hoping for. So we can see on these terraforming pieces what change to the board they're going to make. Great. So now, I think the only other thing I want to do is make a list. Let's see, I guess what I'd really like to do is have these terraforming shapes randomly assigned. Ooh, okay, that was interesting. So if I move this here, if I move this piece, it actually puts an empty color on top. So that's actually a problem. I want it so that if there's nothing to push down, it doesn't actually destroy the shape. So let's fix that. So that is here with colors pushed. So actually, this is going to be different. We're going to get our tile. So let's uncurry this. What I want to do is if there's no tile, is that right? Let's see. Well, there's a couple things. We want to say if there's no color to push, then, yeah, that's what we want to do. If there's no color to push, then we want to just keep the existing tile. So let's see. Let me write this as a case statement first, and then we can figure out if there's a more concise way to write it. So we'll say case color of, and if there's no color to push, then we are just going to return the tile. And if there is a color to push, then we are going to maybe .map push top color with that color onto the tile. All right, let's try that out. Okay, So this piece should move as normal. Great. And then this piece should not erase these two yellow spaces above and to the right. Okay, great. And now if we move it, it should bring all those along with it. Okay, cool. So that's working the way I want it to. All right. So let's make sure everything works if we also have the white pieces be terraforming pieces. Okay, so they render properly, and if I move one, great. Looks like it works. Cool. Okay, so then the final thing I want to do for today is, let's see, I want to choose a random shape for each piece. So let's make a new definition up here, possible shapes, which is going to be a list of these shapes. And each shape is a, let's actually put a type alias for that. Let's see, anywhere set int is, we're going to instead call that a terraforming shape. And we'll have a type alias for that. Terraforming shape is a set of ints. Okay, then possible shapes is going to be a list, and we'll start with this one. And I think what I just want to do for now is make these kind of the standard Tetris shapes. So we'll have 1, 2, and then -1. So there's 1. So that's the line shape. Then we have a square shape for Tetris, which is 1, 1, and 1, 0, 1. Then we also have, let's see, so we have the T shape already, and then there's the two L shapes in different directions. So that'll be 0, 0, 1, 0, -1, 0, and then I guess 1, 1 for that case, and 1, -1 for the other case. Okay, and that should be it, right? There's only 5 Tetris shapes. So the other thing we want to do is, let's hook this up to, well, I guess we can do a quick step here first. So this we will just take possible shapes, and this is temporary code, so let's just stick it in here. Then we're going to list.drop some amount, so there's 5. So we'll take I mod 5, and then take list.head, and we will then list maybe.withDefault, and this should never be a nothing because there should always be an item at that location. So I'm just going to debug.crash, and again, this is just temporary code. And then we will take the same thing and stick it here for the moment. Okay, so this should give us a different shape on each piece. And nope, we had a crash, so I'm going to guess that this just needs to be 4. Nope, alright. Ran into a debug.crash. possible shapes, list.drop, then list.head, and I should always be between 0 and 4. Okay. Let's debug.log here. Uncaught error on board on line 81. Oh, I see. It's doing that one first for some reason. Let's stick this in too. And it's not actually printing that. Let's see, do I have other compile errors? Possible shapes. Yeah, I'm expecting this to print out what's happening right before there. I guess we can just set a breakpoint here and see what's going on. And here, board, constructor tuple, pieces is empty built-in. Okay, well, that's not giving us access to the values I was hoping for. Yeah, okay, here's kind of the list object. 1, 2, 3, 4, 5, 6, 7. Ah, so that's our range list. All right. So if we just say drop 1, that should work. That should always work. And it's not. Okay, does drop not do what I think it does? And is possible shapes not our full list? Terraforming piece, possible shapes. And if we take this out, it should totally work, right? No. Oh, I see. I guess this is because it's evaluating debug.crash, which means we have to put that in a lazy. Okay, well, let's just stick another set in here. In that case, okay, and then instead of 1, we are going to say imod 5. There we go, and they all get different pieces. This one should move like that. Nice. Okay. Then we don't need these debugs. All right, so now let's do our final step for this morning. So rather than just assigning these in order, let's assign these randomly. So in order for that to happen, we are going to require a random seed get passed in to our new function. And we will use the random seed in here. And to use it properly, we're going to need to, every time, produce a new seed and pass it through. So that means in our fold, we're not accumulating just a dictionary anymore. We're also accumulating our random seed. So that means pieces, and we'll get the seed here. And that means we want to return both the new seed and the new set of pieces. Okay, so we're going to need a let block for that, and we'll call this one seed 1. We're going to get back a player 1 shape, and that's going to equal random dot step, I think it's called, and we're going to say random dot extra dot sample from our list. Am I remembering that right? Let's check the docs for the random extra package. Random.extra.sample takes a list and gives back a maybe something. Okay. Cool. So we are going to sample our possible shapes. And pass in the first seed. And then we'll do the same thing for the player 2 shape, except we're going to generate a third seed and pass in our second seed. And then we are going to return back our pieces and the new resulting seed, and then that seed will get fed into the next step in this fold. So then here we have our player 1 shape, and let's see. So then this is going to be a maybe. Yeah, so let's do this. We are going to take the P1 shape and then maybe.map it into a terraforming piece, and if we don't have one, if we didn't get a shape, which we always should, but just in case we don't, we'll put a with default basic piece on there. And this will be the same thing we will do for player 2. Alright, and then we need to import random and random.extra. And we may also have to install the random extra module. Nope, looks like we already have it. Oh no, nope, okay, it's giving the error at the top. So let's kill Elm Reactor for a moment, and we will install Elm community /Elm random extra. Is that the right name, or is it just called random extra? Yep, okay. Elm community /random extra. Hey Wandable, welcome to the chat. How's your weekend going? Then we will start up Elm Reactor again. Oops. And where is our window? Here it is. What does this mean? Given key is not an element in the map. That seems like a weird error, first of all. So I am just going to delete my Elm stuff, build artifacts folder, and run Elm make directly and see if we still get that error. Not sure what it means. Okay, that looks better, or at least like a more normal error message. Yeah, there we go. Okay. So our argument to function board is causing a mismatch. Pieces is supposed to be, a dictionary of position, okay. But we accidentally gave it the seed as well. Okay. So where is that? That's here. Ah, I see. So we end up with this tuple, and once we do this fold, we needed to have the seed in the state of this fold, or in the accumulator. So then once we're done, we're going to take just the first element out, which is our dictionary that we were building, and we're going to throw away the random seed because we're done with it at that point. All right. Now, main needs to be fixed because we need to pass a random seed in order to generate our board. So that means we're going to need to modify our model a bit. Excuse me, I'm going to sneeze. Pardon me. Right. So, let's see, I'm going to stick this back in my preview window. All right. So because we need a random seed to generate a model, let's see, the random package has an initial seed, but we need a way to get that. And I think the best way, let's see, is there a generator of seed? Or I guess there's like a generator of random int. We need basically a way to just get a random seed to start with. And I guess I'm surprised there's not a command in here that just gives us a random seed out. But I guess we can make one. Seems a little funny. Let's check the random extras package and see if there's anything else that's useful to us here. Is there anything about seeds? Initial? Nope. Okay. So we're going to have to set that up, but that basically means we're going to have to fire off a command to create our initial seed, which we'll need to generate the board. So that means there's going to be a moment here where we don't have a board, so I'm going to convert this to be a maybe board. That means when we start, we'll have nothing there. Then we're going to need a new message type, and we'll call it initial seed. And that's going to get a random.seed. Or I guess we can call this create game, I guess. And it'll take an initial seed to kick it off. We're going to need to import random. Then, what's going on here? Ah, right. So we need at this point to essentially destructure the model.board. So I think we can just take this and use maybe.map. So I'll rewrite this to be model.board. We'll pipe that to maybe.map with this function with the last argument curried. Cool. So that works for that. What else do we need to fix? Right. So we need to essentially do the same thing here. And here I'm just going to put a case statement in. And if we get nothing, then we will just return HTML text with no content. If we get the board, then we will take this and do that with it. All right. And our final problem is we need to handle this new message. So if we get a seed, then I guess essentially we're going to take our model and we're going to put our board into it. Actually, I think I'm just going to set this up to create a completely new model from scratch because we want to reset everything else when we start a new game. So board is going to equal board.new and pass our seed into that. And selected tile is going to equal nothing. And we're going to have no command. And this needs to be in a maybe. All right, so that compiles. We're going to have an empty screen so far because we haven't kicked off our command to generate a random seed. So let's do that here in our init. We're going to say random.generate. And I think I'm just going to generate a random integer and turn that into a seed. I guess the other thing it was suggesting is if we get a timestamp. Yeah, here. We can get time.now and get the time value and convert that into a random seed. Okay, let's do that. Time.now, and then we're going to, that gives us a task, so we want a task.perform. And what we want to do with that time value, if it's successful, is we want to convert it into a seed. So I guess we need to do a toInt. Then we're going to convert it to a random.seed. And then we're going to stick it in our message, which is create game. And it looks like we need to import time. And we need to import task. And then we need, oh, I see. We, I guess, want to floor this float to turn it into an int. And this is actually called initial seed. Okay. There we go. I guess maybe a more, let's see, readable way to write this is we can say task.map and do this here. And then this maybe is more understandable of what it's doing. We're getting our time value, then we convert it to an int and make it into a random seed. And then here's where we convert it to a message. All right, let's see if that works. So there's our new board. And all these pieces are randomized, it looks like. Yeah, great. And every time we reload, we get a different distribution of terraforming pieces. Nice. And let's see. I want to try moving this one. Yep, there we go. Cool. So that's where I'm going to wrap it up for this morning. If I have time this evening, I'm going to try doing one final step on this board game idea, which is to have kind of these board transformations animate a bit so it's more obvious what's going on. And then maybe also a nice thing to do would be to have the kind of shapes here be rotated. Also depending on the random seed, but we'd have to write a little helper function to do that. So yeah, here's where I'm going to leave it for this morning. So thanks for tuning in, and I will see you all next time. Have a great afternoon.